Okay, so now that we are more comfortable with the basics of the section, we can start looking at some more complex examples. So in this video, we'll be looking at simplifying single terms. So what do I mean by a single term? Well, basically that we are just multiplying and dividing. We're not adding or subtracting. So in other words, we'll be looking at something like A times B, okay, instead of A plus B, okay. So this is what we're focusing on, okay. Whether we are looking at something in the form of a fraction over C times D, okay. So yeah, we won't be looking at things like A plus B over C plus D, okay. So yeah, in this video, we're not adding or subtracting, we're just looking at multiplication and division. Okay, so let's look at some examples. So 1.1 says, so we have 9 to the power n minus 1 multiplied by 27 to the power 3 minus 2n over 81 to the power 2 minus n. Okay, so we actually had a similar example in the previous video. But in this case, we have a bit more hefty exponents and our bases are a bit larger. So how would we approach something like this? If they ask you to simplify this. So first of all, just notice that we don't have any pluses or minuses. We are working with single terms. So at the top of the fraction, you have a single term because you have something multiplied with something else. And at the bottom, we only have one thing. So we don't have to worry about factorizing anything for now. So how would we approach this? Well, we want to be able to apply our exponent laws, right? In other words, if we're multiplying things with the same base or dividing, we can add or subtract. So looking at this fraction as it is, we can see, let's just examine the bases that we have. We have a 9, we have a 27, and we have an 81. So the best thing I think we should do is try and break these bases down into simpler bases and try and see if we can find a common base and then apply our exponent laws to then simplify this fraction. So okay, so let's start at the top. So the intuitive thing to do would probably be to simplify the base to as small a base as possible. So if we look at the 9, what's the smallest thing we can break that down to? Well, technically we can say 3 to the power 2, right? But 9 was already raised to a power. It was raised to n minus 1. So outside of the brackets, we have to add n minus 1, okay? Because 3 to the power 2 is technically 9. Okay, cool. So now we consider 27. Is there something that we can break it down to? I mean, if you look at 9, we broke it down to a base of 3. And can we do the same for 27? Yes, we can. We know that 27 is technically equal to 3 to the power 3. Cool. And 27 was raised to the power of 3 minus 2n, so we'll just add that there as well. And then lastly, 81. Can we break that down further into a smaller base? Yes, we can. 81 we can write as 3 to the power 4. And then we just have to add the 2 minus n. Awesome. So what you'll see now is that we have a common base of 3. And now we can definitely apply our exponent laws and we can simplify this fraction. So let's just go and simplify what we've just written over here. So we have, at the top we have 3 to the power 2, and that whole thing is raised to the power of n minus 1. So you'll distribute the n minus 1 into the brackets. So you'll say 2 times n minus 1. So we'll have 3 to the power 2n minus 2. Okay. Then we multiply that by the next piece, which is 3 to the power 3 in the brackets. And then outside of the brackets, we have raised to the power 3 minus 2n. So you'll say 3 times 3 minus 2n. So this will give us 3 to the power, okay, 3 times 3 is 9, and minus, so 3 times negative 2 is just negative 6, so it will be minus 6n. And so at the bottom we have 3 to the power 4 inside the brackets, all raised to the power of 2 minus n. So we'll multiply 4 with 2 minus n, so we'll get 3 to the power 8 minus 4n. Awesome. And now it's definitely clear that we have a common base of 3. And now all we have to do is apply our exponent laws. So we know that we have a common base of 3, so we might as well just write down 3. Okay. So now starting at the top, okay, let's start over here with a 3 to the power 2n minus 2. So at the top we have 2 3's as a base. Okay, so we'll start with this guy. We have 3 to the 2n minus 2 multiplied by 3 to the 9 minus 6n. Because we are multiplying and we have the same base, we will simply add up the exponents. So we'll say 2n minus 2. So let me just quickly write that down. We'll have 2n minus 2. And then we add the 9 minus 6n. So plus 9 plus negative 6n. So minus 6n. Okay. And now at the bottom, we have 3 to the power 8 minus 4n. So whatever you have over here now, you'll have to, or at the top, you'll have to subtract this 8 minus 4n. Okay. Just be careful with your signs. So you'll say minus 8 minus negative 4n. So that becomes plus 4n. Awesome. And now all we have to do is just simplify the exponent. So we have 2n at the, let's look for all the n's. So we have 2n minus 6n, which is just minus 4n, plus 4n is 0. So the n's cancel out. Okay. And then we can look at, we have a minus 2 plus 9, which will just give us 7. And then 7 minus 8 will give us minus 1. So we have 3 to the minus 1. And of course, we know that we don't like to have a negative exponent, so we can just take that to the bottom and we'll end up with a third. And that is your answer. Alright, so our last example, 1.2. This one is a little bit of a step up from the previous one. So we have 10 to the power 2x multiplied by 25 to the power x plus 1. Okay, x plus 1 multiplied by 2. So that's technically 2 to the power 1. And at the bottom we have 50 to the power of 2x minus 1. Okay, so just as in the previous example, what do we want to do? We want to try and find a common base. Okay, it doesn't necessarily have to be like in the previous example, we had everything had a common base of 3. We can find more than one common base as long as we can try and simplify this. Essentially, you'd want to try and get rid of the fraction form. You want to get this, you want to get rid of the fraction. So how can we do this? So let's consider everything, all the bases we have here. So we have a 10, a 25, a 2, and a 50. So 2 is very simplified, okay? This guy over here. So we're not really going to do anything with him. So since we have a 2 there, this kind of hints to us what we need to try and do for the rest. So if we can try and find bases for these guys containing a 2, not necessarily all of them, it just hints one of the bases you might want to try and find. The first thing you'll notice, so we want to try and simplify these or break these down into simpler bases. So I'm going to leave 10 to the power 2x for now and 50 to the power 2x minus 1. And you'll see why now. So if we look at 25 to the power x plus 1, what can we break 25 down to? We know 25 is technically equal to 5 squared, right? So let's go and write that. 5 squared, okay? And then outside of the bracket, we have x plus 1 and multiplied by 2. Okay, and the reason I did this is because it's easy to just say 5 to the power 2. There isn't really something else you can break this down to. When looking at 10 and 50, we're going to have to break it down to more than just one thing to the power of another. We're going to have to say one thing multiplied by another thing to the power of something. Okay, so yeah. So now we've got two very simplified or two very small bases. We have a 2 and a 5 as a base, right? So that's basically our goal. Can we go and simplify this 10 and 50 to give us a 2 and a 5, either or both, doesn't matter. You know, we're just trying to kind of simplify this fraction right here. So looking at, let's start with the 10, okay. So 10, what do you have to multiply together to get 10? And convenient enough, you can say 2 times 5 to the power of 2x, right? Because 2 times 5 is 10. So inside the bracket, if you just multiply it, you'll just get 10 back. So it's the same thing. And then I'm just going to go and simplify this guy over here. So we have 5 to the 2 inside the bracket, and that raised to x plus 1. So you'll just distribute the x plus 1 inside. So you'll say 2 times x plus 1. So we'll have 5 to the 2x plus 2. And then this is just multiplied by 2. I'm going to say 2 to the 1. Just to help us when we are trying to use our exponent laws. And then at the bottom, we have 50 to the power 2x minus 1. Is there a way for us to break that down to give us a 2 and a 5 as a base? Maybe only one or maybe only the other. Well, we know it's not going to be only one. So what we can do is we can write this as, well, let's think. 2 times 25 is 50, right? But 25 we saw we can write as 5 to the power 2. So technically 50 we can say is equal to 2 times 5 to the power 2. And that whole thing is raised to 2x minus 1. And what do you see? We've literally managed to break all of this down into a base of either 2 or 5. So we do have a common base now. We have more than one, we have 2. And now we can just go and simplify this. So, okay, so let's see. So simplifying this now, we're just going to distribute the powers into the brackets. So we have 2 times 5 to the power of 2x. So we'll multiply that inside. Let's just see here. So we'll have, so it's distributed on the 2. So we have 2 to the 2x multiplied by 5 to the 2x. Okay, and that whole thing is multiplied by 5 to the 2x plus 2, and here we still have our 2 to the 1, and at the bottom it will simplify to, so we have 2 times 5 to the 2 in brackets raised to the power 2x minus 1, so we'll distribute the 2x minus 1 onto the 2, so we'll have 2 to the power 2x minus 1 multiplied by, and we have 5 to the 2, so we'll say 2 times 2x minus 1, which becomes 5 to the 4x minus 2. Awesome. And now we can definitely see that we have a common base of 2 and 5. And now it's very easy. Now we just have to add and subtract, depending on whether we are multiplying or dividing. So at the top here, we have a 2 to the 2x, and we have a 2 to the 1. And at the bottom here, we have a 2 to the 2x minus 1. So let's start by just writing down the 2. And at the top, we have a 2x. Okay. We're multiplying that with the same base, 2 raised to the power 1. So we just add the 1 because we're multiplying. Looking at the bottom, that 2 is raised to the power of 2x minus 1. Since we are dividing, we have to subtract that. So we say minus 2x minus negative 1. So that becomes a plus 1. Awesome. And now all that's left is to add the 5. So we'll multiply this. We'll multiply this whole thing here by 5. Sorry, that looks funny. Okay, 5. And we'll start at the top. We'll start here with 5 to the 2x. Okay. So we'll have 5 to the 2x multiplied by So here we have another 5 to the 2x plus 2. So since it's the same base, we're just adding the exponents. So plus 2x plus 2. Okay. And at the bottom, we have a 5 to the 4x minus 2. So we're just going to subtract that. So we'll say minus 4x. And we have a minus negative 2. So that becomes plus 2. Okay, cool. And now it's really easy. Now we just simplify this answer. So we have 2 to the 2x, but there's a minus 2x as well. So the x's will cancel out. And we have a 1 plus 1, so that just simplifies to 2 to the power 2. Multiplied by, now for the 5, if you just check, you'll see your x's will cancel out, and you'll have 5 to the power 4. And then obviously this simplifies to 4 times 625, and then your answer will be 2,500. Awesome.